Welcome everybody from the ad break. Hopefully you've taken a break. Just want to send another big shout out to Liberty. Thank you so much guys for sponsoring the show. Truly appreciate it. Without you guys, none of this could have been possible. So right before the ad break, we had just finished doing multiple choice. Now in this segment, what we're going to do now, we're going to look at more questions, which is paper number 2. But now we are doing all about organic chemistry. So Lerna has sent through this question and said, oh my word, Tops, please help us. So now before I answer this question, I want to go back on a little bit of theory. If ever we are talking about different types of reactions, before you even read the question, you need to know what the reaction actually has. For an example, if we have an addition reaction, it means that you are adding something that was never there. In chemistry, when you add, it means that you have to break a double or triple bond and add something that was never there. Now, if you have to substitute anything, something in soccer, when they substitute a player because somebody's not playing right, you remove somebody else and in place of that person, you put something else. No bonds are broken, no new bonds are formed. You just substitute two things, right? And that is then again a reaction. And then again, you have what we have, an elimination. You are taking something away. When you take something away in chemistry, it means you are forming double bonds so that you can have another product. Now remember, if ever you are eliminating, adding, subtracting, and so forth, the mistake that some of you guys make is that you end up not counting the number of carbons around. Remember, if you're having an elimination reaction, you must have a double bond and then your number of hydrogens will then not be the same again. Another thing, you need to start remembering and realizing that if you are adding, breaking and stuff, you form a major product and you can form a minor product. We've got two laws that help us with that, Markovnikov and Zaitsev's rule. You need to know it off by heart. I would also actually say name the definition. I really haven't come across one like that, but I would always say you never know what the examiners are thinking. I would rather be over-prepared than under-prepared. So let's look at this question and then we're going to elaborate it further. So it says the flow diagram below shows how an alcohol, so we know it's an alcohol. How do we identify an alcohol from our organic chemistry notes? It'll have an OH. They don't tell us what type of alcohol. They just say an alcohol, which is compound number P. I can already see, this is compound number P here. It can be used to prepare other organic compounds. So we have letters A to E, which represent different organic reactions, which is X and Y, and Z, which are organic compounds. So let's see what's going on over here. So here we've got compound P. I can see I can move it to A. If I move it to this way, I have an alkene. Alkene tells me that something was removed and then I have a double bond. If I move back at B, whatever B is, it breaks that double bond and it makes me or gives me the alcohol that's present here. Let's see what's happening here. I have the alcohol, I can add some HBr, something will happen, or I can take this reaction with HBr and move back to the alcohol at hand. Whatever I will have once the HBr is added, I see that going all the way up here, I have a major product, right? And the major product is the alkene where something was removed. Then I've got reaction number E, which is going down here. That is compound number Z. I can see I've got a catalyst, substances that speed up the reaction rate without actually undergoing any physical change. And then I've got H2 gas, which is hydrogen gas. So that is the whole thing that's happening. Already in my mind, I need to know something was added, something was subtracted, and so forth. So let's read 4.1. 4.1 says, is compound P a primary, a secondary, or a tertiary alcohol? So the easiest way I can remember, primary means, you're in primary school, there's only one. Secondary, you're in secondary school, high school, 2. Tertiary, it's your third way or field of learning, so there's 3. What do I mean by this? Let's take this further. If you have a primary alcohol, you have a C with an OH only attached to one other carbon. Remember your H's, otherwise it does not make it an organic molecule. Just put an H there. So here you get the concept. I'm not going to do the H's anymore so that I don't waste any time. Secondary alcohol, you can have the C attached to an OH. However, it will be attached to 2 other carbons. Remember, secondary, your second form of learning. Then you have tertiary. A tertiary alcohol means you have the central carbon, which is an OH, which is then attached to 3 other carbons around it. primary, only 1. Secondary, we've got 2. Tertiary, 1, 2, 3 to the central carbon. So let's see. Let's see which one of the given ones is then number P. So is compound P a primary, a secondary, or a tertiary alcohol? Let's go back here. Here's the C attached to the OH. It only has 1 other carbon and then 2 other carbons. So it means 4.1 is a secondary. There are 2 amongst it. That is 4.1. Let me write it here. Number 4.1. It is a secondary alcohol. It is a secondary alcohol. Let's look at the next question. So number 4.2 says, write down the type of 4.2.1, the elimination reaction represented by A. So when I come through here, let's just erase all of that. Take all of that away so we have a new slide. The elimination reaction represented by A. So here I've got an alcohol. Remember, an alcohol has got an OH. And then all of a sudden I've got an alkene. At A, I must eliminate something. Remember, if I eliminate the OH, I will eliminate an H as well, which means I will eliminate water. When you are removing water or eliminating water from a reaction, it's dehydration. Think about yourself. When you are running a marathon and you're trying to keep up with everyone else, you get dehydrated because you need water. An elimination reaction at A is a dehydration reaction. Dehydration. How do I know that? Because when you are eliminating from an alcohol to give you an alkene, you have removed an OH with the H to give you water. Number 4.2.2, addition reaction represented by B. So here we've got addition reaction by B. Now remember, here I'm going to have my alkene. I just want to take it a little further. I'm going to just remove the alcohol. So now it means I'm going to have a double bond between the two. Now the addition reaction moving B is the reverse of what A is. If A was dehydrating because it was removing water, the reverse is that. If you are really thirsty because you are dehydrated, you need to hydrate. You need to hydrate. So B is the opposite of dehydration, which is then hydration. 4.2.2 will be hydration. If you have got a double bond and you add water to it, you are adding H2O that will be bonded as H and OH. The H will bond there again and the OH will bond here again. So that is the opposite of dehydration. So let's look at number 4.2.3, the type of elimination reaction that occurs at D. Now look at this one very crucially, right? It's pretty simple. Here we've added HBr, right, which is hydrogen with a halogen, right? We've added it and then we get compound number X. At D, we remove that one. How do I know that? Because it is an alkene. The same alkene where we had removed the OH and the H to give us water, and then we just had a double bond there. So we add HBr, D we eliminate it, and then we go back to the alkene, which means eliminating of anything to get us a double bond. We say D. The H will represent hydro. The B will be halogenation. So it will be dehydrohalogenation. D for eliminating, hydro for my H, my Br for being a halogen. So we're going to add all of that together. 4.2.3, it is dehydrohalogenation. I have removed a halogen. I've removed HBr. Some textbooks actually will have it as dehydrobromination, which is also not wrong. Dehydrobromination, which is also not wrong. But you have to have the D to actually indicate that something was actually being removed, right? And that is then how we got the alkene. Now we are at 4.3. So now we are given further information. We are told that sodium hydroxide, NaOH, is used as one of the reactants in reaction number C. Let's go find C. Just remove all of that again. Let's find reaction number C. I can see that we have the organic compound. Remember, the same organic compound where HBr was added, right? Now we are talking about reaction number C, which is moving back. So now let's see what further the question says. What type of reaction takes place here? Now remember, we will have had HBr and then we'll just have OH on here. Nothing was taken out. There's no enes, there's no YNE, so there's no double bonds or anything. It means that something was put in place of something else, right? So for example, like here, you'll have the H and the Br, which will come into place with the O and the H, which means something must come in place of that. Remember, like in soccer, if we replace a player with somebody else, we substitute. This means it is then a substitution reaction. This is 4.3.1. It will be substitution. Substitution reaction. It's not also wrong if you say hydrolysis. I'm just going to leave it at substitution for now. Let's look at this one, 4.3.2. Let's see what this question has for us. So here it says we must state two reaction conditions for this reaction. Now, I just want to elaborate further on this one. If you're talking about reactions and you're talking about different conditions, it means what must actually happen for a reaction like this to take place. Remember, some reactions might need sunlight. Some reactions must be cold, or they need a catalyst, and so forth. So now this means we need to look at what is actually happening there and see what reactions conditions do we need for this reaction to take place. So let's see. So at compound number C, state two reaction conditions for this reaction to take place. Let's go back. For C, remember I have to have an OH, so I need to have a dilute base, NaOH, and a moderate amount of temperature, right? That is what I learned from my theory from my organic chemistry. So they said any two, but I'm going to give you three that you can choose from. A dilute base. Remember, if you use a dilute base, it actually gives you the NaOH, which could be NaOH. It will give you the OH rather for the alcohol, and you need moderate heat. You need moderate temperature or heat. Let me just say dash there, or heat. That is also not wrong. So let's see what 4.3 has for us. The next one says, write down the IUPAC name of compound X. IUPAC is a system used in applied chemistry to name organic molecules the correct way. So before we actually name compound number X, I want us to go through all the laws of how to name organic molecules. Step numero uno, you have to find your longest chain. Now guys, I see some of you guys are so scared if the chain starts bending and stuff like that. A chain is allowed to bend as long as you find your longest chain. And then you have to find all your side chains. However, if you do have a double bond, your double bond must always have the smallest number, right? And not your side chains. Double bonds are first preference to side chains. Next thing, once you start naming all your side chains and all that stuff, remember to put all your side chains in alphabetical order. For example, you'll put bromine or chlorine first before methane, ethane, and so forth, right? So make sure that everything is in alphabetical order. You have your longest chain, and do not forget to actually indicate in where is your double bond, right? If there is no number, the examiner will assume that it's on the first one. You must always indicate that. Most of you guys make that mistake. Now that we've looked at the theory, let us name compound number X. So let's see where X is first. So compound number X is this one here. Let me just remove all of this again. So this is then compound number X. I can see that I have the alcohol here, and I see that I'm going to add HBr. Remember that it will dissociate to H plus and then Br as well. It will substitute something else. So I'm going to write out the full one for number 4.3. 4.3.3, I'm going to do it step by step. I'm going to start with the alcohol. There are 4 carbons on the second one. That is where the alcohol is. Remember to not forget your H's. If there are no H's, it's not really an organic molecule. There are no double bonds around this one. I'm going to add HBr. I'm going to have H. I'm going to have Br. Now, what's going to happen here? My OH is going to be substituted by my Br, and then I'm also going to form water. So this OH is going to bond with, let me just write substitute here, substituted by my Br, and this and the H will then form water. So let's write the new one. I'm going to write it exactly as it is. I've got 4 carbons. Where the OH was, I'm going to substitute it by Br. Remember, the examiner wants to see that you understand the concept and that you actually understand the laws and principles of physics as well. So I'm going to have HH there and so forth. Now the OH and this H, if you've got an OH plus H, 2 H's give me H2O, which is water. So I also produce water as H2O. The examiner wanted this full-on reaction here. So what you only needed to know is that the OH will be substituted by the Br, and the OH from the alcohol and the H from the hydrogen bromide will then form water as another product. For how many marks was this one? So this was then just for 2 marks. Let's look at number 4.4. It says write down the formula of the inorganic reactant needed for number D. Let's see what's going on at number D. I can see that, at number X, this is what I have here. This is my number X with the Br being substituted in place of the OH. But now at number D, I can see that number D is actually taking me back to an alkene. An alkene, meaning it has double bonds, means something was eliminated, right? If something is eliminated, it means that I need NaOH or potassium hydroxide for the elimination. That's what the question is saying. I must write down the formula of the inorganic reactant needed for reaction D to take place. For the Br to actually be eliminated, I'm going to need something. So this will be 4.4. So what is required for the elimination reaction is NaOH, or you need KOH. That is what you'll be needing. Let's look at the next one. So number 4.5 says use a structural formula. Now you need to know the difference between structural formula, condensed structural formula, and all that stuff. We must use the structural formula to write down a balanced equation for reaction number E. Let's see what's actually happening at number E. Just take all of this off. So at number E, I've got my alkene, which is a double bond, and I can see that I'm going to add H2, which is then a gas. I'm going to move from an alkene by breaking the double bonds and making them single bonds, and therefore I will form reaction number Z. So it is then an addition reaction. I'm adding something that was never there. How do I know this? Breaking the double bonds, making it single bonds by putting or adding the H2. The question says we must write a balanced equation for this. See if I've got enough space here. This will be 4.5. Let's do it step by step, the alkene. I just want to also add on to this quickly. They did say the major product. Remember what I said, there's a difference between major and minor product. You must read Markovnikov and Zaitsev. In this case, the major one will be my C. There will be a double bond. Remember on this C we had an OH. Let me just write it quickly and then eliminate it again. Let me do it the long way around, just so that everyone understands and is with me. We have a C. Let me just put all my H's. So initially, this is how the organic molecule looked. It looked like this, and then something was eliminated, right? We eliminated it. The OH was moved, which also meant that we were going to form a double bond. So we form a double bond there. My number of lines around each carbon is still the same. I am told I'm adding H2. Remember, this is H and then an H. The question said a balanced equation. So with these two H's I'm going to put them in place of that by breaking the double bond. I've got my 4 C's. I've broken my double bond. I'm going to have my hydrogens around my C's. So we move from an alkene to an alkane. Where there was nothing before here, I'm going to add my hydrogens. And therefore, I've got an alkene here, a double bond. I have added my H2 gas. Now I've got an alkane. Oopsie daisy, I forgot one H there. And there we are. That is then balanced. Let's look at our last question. So the last question says, write down the IUPAC. So already you can see IUPAC is the applied chemistry method of naming different organic molecules. We must write down the IUPAC name for compound number Z. So compound number Z is the one that we just actually did the balanced equation for after we have added the H2 gas. Now it says we must then go and name it. I am going to do it the long way around just in case somebody does not understand or does not get it. I'm going to use this one over here. My longest chain is 4 carbons. 4 carbons in chemistry is bute. Remember, 1 is meth, 2 is eth, 3 is prop, and then 4 is bute. Now, I only have single chains. I'm just going to write single here. Remember, if something only has single chains, the name ending will be ane. From this diagram here, there are no side chains, there are no double bonds, there's no functional groups and so forth. It is what it is, exactly like that. So I can quickly go to 4.6 and I'm just now going to put it together. My longest chain is bute. My name ending will then be ane. So it is butane. If ever you actually had to name a structure, I would always go back to the structure and see if you can actually redraw it. Bute means 4. I do have 4 carbons. Ane means there are no double or triple bonds. There are no double or triple bonds in this section. So 4.6 is then butane, which makes that then correct. Another thing I just want to add with you guys when you are naming organic molecules, most of you guys tend to actually forget if there's 2 of the same thing, you must always remember to put in the word di. In this case, this was actually a very easy one. There was no word di, but if you had to, you must always say di and try if there's more than 3 and so forth. That's just the rules of chemistry. But that is then how we have answered the organic molecule questions.